All right, in this last video, we're going to take a look at how to solve logarithmic and exponential equations by graphing, which means using your graphing calculator. So we want to make sure we have the skills of solving by hand so we understand how these work. And then solving with your graphing calculator, it's a nice way to check an answer. Or if we can't apply the properties we've learned, that's always a backup way to solve an equation. So what is the solution to log of 2x plus 1 to the 5th power equals x minus 2? So we are going to have two equations that we'll put into our graphing calculators. So the first one is going to be the left side of our equation. So we would, in our y1 on our graphing calculator, we would type that in. However, do you see how it's 2x plus 1 raised to the 5th power? So when you're taking the log of something that has an exponent, the exponent does need to drop down in front. So we would type in 5 times log of 2x plus 1. That's the left side of our equation. And then the right side of our equation would be y2 equals x minus 2. Now that's just an x to the first power. That is going to be linear. It's going to be just a straight line. But we would type in both of those to your graphing calculator. We would look at the graph and analyze, or just have the graph calculate the intersection point. Where does this function cross this function? All right, so here are some screenshots of what you would see on your graphing calculator. If we look at, well, let's just look at this one on the left first. So the blue line, that's that linear function, x minus 2. It's going through the y-axis at negative 2, slope of 1. So this is the x minus 2 side of our equation. The red, that's the log side. That's 5 times the log of 2x plus 1. What we want to notice is that there are two intersection points. So these two functions cross here and they cross there. So what I did was I just had it calculate both intersection points. So this first, where it says intersection x and y, that is for that intersection point right there, that first one on the left. Now, because our original equation has all x's, yes, that is the ordered pair where those two functions cross, but it's the x value that would be the solution to the equation. So x is equal to that x value right there, a negative 0.329. So that's one of the solutions for x we got from our graphing calculator. Then what I did was I had the graphing calculator calculate this intersection point over here, and it gave us this intersection point goes with that one right there. So I would grab your graphing calculator, type both of these in, see if you can remember how to calculate those intersection points. It's a good skill to have. You want to make sure that when needed, we can do this. So the other x value, we're getting two values of x, is this 8.204. And those are our two solutions to the equation for x. And the reason why we have two, when we graph both sides of our equation, we can see that there are two intersection points. And again, it's the x values of the intersection points that are solutions to the original equation.